Hi, this lesson is an introductory lesson to trigonometry. Now there are some points we'll need to go through and please write down any important points, especially if they're new to you. Now trigonometry is something that it's easy to understand if it's explained properly to you, and it's the relationship between the side lengths and angles in a triangle. And at Year 9 level we work with right angle triangles, and we have worked with these when we did Pythagoras. So once again, it's the relationship between side lengths, so lengths of a right angle triangle, and the angles inside. Okay, and we know a triangle has three angles that add up to 180 degrees. And with this topic, you always have a right angle. So one of the angles will be 90 degrees. Now, there are three trigonomic ratios that you have to remember. And we always write them in the shorter version, but the long version we say sine. For short, it's S-I-N. A lot of students pronounce it as sin, but it's actually, you still say sine. The second one is cosine, or cos for short. And the third one is tangent, or tan for short. So sine, cosine, and tangent are the three trigonomic ratios. And we say, the shorter way of saying it is sine, cos, and tan. There's also a symbol that we use for the angle. So when an angle isn't given to you, like for example 20 degrees or 30 degrees, the symbol we use, I couldn't find the actual symbol, so I'll quickly draw it that you'll see. It's called theta. So this symbol here, you'll see it quite a bit. It's called theta. It comes from the Greek alphabet, and we use this to represent an angle. So just say you see this symbol in a triangle. Oops, sorry, that didn't come out right. So if I draw a right angle triangle, there's my right angle, and in this angle here, I could say it's 2 degrees, just say, and down here I've got this symbol. Because they haven't given us the symbol, the actual angle, we can use this symbol. You can use other symbols, but the most common one you'll see is theta, and I call them a Pokemon ball because it sort of looks like a Pokemon ball. So it's just a circle, I guess, or a zero with a squiggly line in the middle. That's the easiest way to draw it. Now each trigonomic ratio, so sine, cosine, and tan, they focus on the angle of a triangle and also two specific sides of a right angle triangle. Okay, so each one focuses on two sides of a triangle. So we're going to go through how to label a right angle triangle. We have started already when we did Pythagoras. Hypotenuse is one of those sides, but there are two other sides we have to understand on how to label. And a way to remember this is using this sort of riddle or saying. It's called so katoa. Okay, so S for sine, okay, C for cosine, and T for tangent. And I'll explain what the other letters mean, other symbols. And it is in your textbook as well. There's in that whole blue section, okay, it goes through all of this as well. So katoa, and it explains what it is. But we'll go through it together as well. So our next thing we'll do is labeling a right angle triangle, all the sides. So when it comes to labeling a right angle triangle, we know the hypotenuse is always opposite the right angle. So there's my right angle. And it's always the longest side of a triangle. So the hypotenuse never ever changes. So that's the hypotenuse. It's always going to be the same line opposite the right angle triangle. And it has to be the longest side. And we learned that with Pythagoras. Now, the other two sides can change depending on where the angle is that you're focusing on. So with trigonometry, you have the right angle, but then you've got two other angles. And depending on what the angle is, or where it's given to you, depends on how you label your other two sides, okay? So with this triangle, you can see the theta symbol is here. They haven't told us the angle. It could be 20 degrees, 30 degrees. That's why I've got that theta symbol. So this is the angle we're focusing on, okay? So I'll do it in red to emphasize that. There it is. And because the angle is up here, the other sides will be now this. So we've got hypotenuse, okay? Now, the other sides can either be this opposite for O, so O for opposite, and then you've got adjacent. So these are the names of the other two sides, and they can change depending on where the angle is that you're focusing on. Now, opposite is simply opposite the angle you're focusing on. There's my angle. Opposite that angle is down here. So this side length will be the opposite. And that means this one here is going to be this side here is going to be the adjacent. I'll write it alongside it if I can. It's a bit tricky. I'll just do it this way. All right, so adjacent. Sorry, it didn't come out good. But this side here is the adjacent. So we've got hypotenuse, opposite, which is opposite the angle given to us, and adjacent, okay? So if I did another triangle exactly the same, if it was exactly the same triangle, there's my right angle, but the angle I'm focusing on is down here, there's my angle, then that's when the side changes. So hypotenuse is the same. There's my hypotenuse, opposite the right angle. But now opposite is going to be opposite the angle. So this will be the opposite side, opposite the angle. And my adjacent will be alongside here. Okay? And that's what the word adjacent means. Adjacent, I spelled it wrong, but you can fix it up. Adjacent means side by side. So it's adjacent the angle. It's right next to the angle. Side by side, side by side. Opposite is opposite the angle, so on the other side of the angle. So that is something you have to be able to do, is to label a right angle triangle. Okay, so hypotenuse, you have a hypotenuse, which is always the same, but then you've got opposite and adjacent, which can change depending on the angle you are focusing on. Okay, so you always have to focus on one angle. Even if they've given you two different angles, okay, you still focus on one and label it accordingly. Now we'll go through exactly what we mean by so katoa in a second. But before we do that, so you know how to label a right angle triangle now. The other thing I want you to go to is to your scientific calculators. Now, if you don't have a scientific calculator for this topic, you cannot do this topic. You must have a calculator every single class from now on, okay? Because you can't manage without a calculator. All right, so if you go to your scientific calculators, I'll just find mine. I want you to locate where you see sine, cosine, and tangent for short. Okay, there's 3 buttons there. Okay, that's what you'll be using quite a bit. Now, I want you to push sine 30. So push sine, put in 30 and close brackets, and you should get a half, or push that SD button and turn it to a decimal 0.5. That's what you should get. If you haven't got that, that's because your mode isn't in degrees. You have to make sure your mode is in degrees. So if you go to shift mode, you'll see my calculator number 3 says DEG for degrees. You got to push 3 and then push equals, I guess, and that's it. That will fix it up. Because otherwise your mode might be in radians. If you see RAD, we don't use radians at this stage. You use it in BCE. So in this stage, please make sure your mode is in degrees. So just do a test, push sine 30. If you don't get 0.5, you have to change your mode to degrees. Now, the next thing I want you to do is to write this down. So katoa, okay, this is what it actually means. And it helps you to remember the trigonomic ratios. So sine, okay, so sine here focuses on the opposite side of a triangle divided by the hypotenuse. Cosine focuses on the adjacent side of a triangle and divided by the hypotenuse. And tangent always focuses on the opposite side of a triangle and divided by the adjacent side of a triangle. So each of these 3 ratios focus on 2 sides, and we just divide the length together. That's all we're doing. That's why S is, so katoa, S is for OH, opposite over hypotenuse. C for cosine is adjacent over hypotenuse, so ka, and toa. T for tan is opposite over adjacent. So that's a way for you to remember each of these 3 things, these ratios, but it's something you have to remember. So please write them down. You can remember it any way you like, but this is the most common way. So katoa. And don't get confused with the commercial on those crackers, sa kata. It's completely different to that, okay? It's so katoa. Now, it's really important to understand how trigonometry works, okay? We can learn all these rules and formulas, but not actually understand any of it, okay? That's how I was taught. We just learned the formulas, learned all these things, pushed it in our calculator, and that was it. But I never actually understood what was happening. So the worksheet you should have received explains or asks you to do a few things to help you understand how trigonometry works. And it's a natural thing that occurs with a right angle triangle. So on the first sheet, I'm going to explain to you what to do in case you weren't sure in class. You were given a worksheet. The first page said the sine ratio, okay, for 30 degrees. So that's the one we're going to be focusing on today. So sine ratio. And you had three triangles. Oops, sorry, what did I... You had three triangles, which I'll just draw. These are the three triangles you had on your worksheet. I've just drawn them quickly. Obviously, they're different measurements, but imagine they're exactly the same. What you had to do was, you notice the 30 degrees, each angle is given to you, and each angle, if you measured it, gives you 30 degrees. It's really important that you realize that. So each angle was measured for you. The other side of this worksheet, when you focus on the cosine ratio, if you turn the page, we've got the cosine ratio. You actually have to measure the angles yourself. And I think they should have come to all of them should have come to 30 degrees. So you had to use a protractor for that. But it's important to keep in mind every angle is the same, okay? For each of these triangles, the angle we are focusing on, okay, is all the same. It's all 30 degrees. Then the instructions were you had to measure the hypotenuse, the opposite and the hypotenuse of each of these triangles. So opposite the 30 degrees was here for this one. There it is, and there it is. Oh, sorry, I labeled it wrong. Opposite should have been here. Oh no, I put the angle in the wrong spot. My bad. So I'll just change it. So the angle on the worksheet was here. Was 30 degrees. Sorry about that. So opposite that. Now, you had to measure the side lengths of the opposite and hypotenuse. The reason why you had to measure those two sides is, remember, sine ratio, okay, so sine and the angle you're focusing on is equal to opposite divided by the hypotenuse. That's the sine ratio, opposite divided by hypotenuse. So you had to measure this length here. Now, when I measured it, I got 2.3 centimeters for this triangle, the first one, for my opposite, and the hypotenuse I got 4.6 centimeters. Now, it doesn't matter if you're not 100% accurate, because it's impossible to always be 100% accurate, okay? But that's what I got when I measured it carefully. You may have gotten something different, that's okay. But the next thing you had to do was, in that table, you had to divide the opposite and the hypotenuse. So I'll just draw the table. They've started off for you. Sine ratio, and because we're focusing on 30 degrees, I've got it there for you, is opposite divided by hypotenuse. So then what was the opposite length I measured? I measured 2.3 for the opposite, and the hypotenuse was 4.6. So then, because ratios, we are comparing two different values or dividing them, we've got 2.3 divided by 4.6. Now, when I put that in my calculator, 2.3 divided by 4.6, I get a half, or 0.5. I write it as decimal. So I got exactly 0.5. If you didn't get 0.5, if you got 0.5555 or something close to 0.5, that's fine as well. Just round it off, okay? Because this is just an experiment. But it should be close to 0.5. For triangle 2, you should have got the same thing. So do the exact same thing, measure the opposite and the hypotenuse. And when you measure it, you should get something close to 0.5. And the same for the third triangle. And that's what's happening. No matter how big or small your triangle is, if you have an angle of 30 degrees in that triangle, so it's really important the angle is 30 degrees that you're focusing on, okay? And you measure the length of the opposite and the hypotenuse, you will always get a value of 0.5, no matter how big or small your triangle is. And that's the sine ratio. That's what's happening. There's a relationship between those two sides. So the angle of a triangle can always be 30, but as it gets bigger or smaller and the side lengths change, okay, we still get the ratio of 0.5. That's why if you go to your calculator again and you push sine 30 degrees, it gives you a half or 0.5 because that's a sine ratio for 30 degrees. No matter how big or small your triangle is, your right angle triangle, it can be as big as the earth. You'll always get 0.5 if your angle you're focusing on is 30 degrees, okay? And that's what you're supposed to do for the other ratios. So for the cosine ratio, do the exact same thing. Fill in the table, and the same for the tangent ratio, okay? And they've given you, for the tangent ratio, you've got 22 degrees. You can sort of get a head start. If you push tan 22, see what you get something close to 0.4. So whatever you measure and divide should be close to 0.4. And that's basically how trigonometry works. Depending on the angle, the ratio of certain two sides will always be the same, no matter how big or small your triangle is. So to practice this, you can go to exercise 3E and complete questions maybe 1 to 8, okay? And 8JM, I'll put this chapter in the folder for you. Thank you.